Hi everyone. I'm excited to talk today about taking machine learning to production with new additions to MLflow. So in today's talk, I'm going to go through a few items. First, I'll talk about the state of production machine learning, and then I'll talk about three new sets of MLOps features in the MLflow project to help with that, namely productionizing PyTorch through a deep integration with MLflow, tracking data, schemas, and explanation, and finally new features in the Model Registry for continuous integration and deployment and general availability of the Model Registry on Databricks. And we'll end with a demo of these new CI/CD features on Databricks. So I think as everyone at this conference knows, machine learning is transforming all major industries. It's already deployed into hundreds of production use cases in each industry, and the number of use cases are just growing over time. But at the same time, building machine learning applications is complex. It's a continuous iterative process because the world that your application lives in keeps changing. And so you have to change the way that you model it and update models, retrain them, retest them, and so on. It's highly dependent on data. So anything that might go wrong in your data or that might change might have subtle impacts on the model downstream, and you need to be able to monitor and fix all the changes that are happening in your data pipeline. And finally, machine learning applications involve many teams and systems that have to interact together. For example, data engineering teams, ML engineering, and application developers, and they all have to hand off models and data between them in a consistent way to get the application to actually work in production. So because of the complexity of building these applications, there's actually a whole new class of software that organizations have begun building to help manage them, which is called machine learning platforms. These are software platforms that manage the ML application lifecycle all the way from data to experimentation and production. And some examples of these are the ones used in very large tech companies such as TFX, FB Learner, and Michelangelo, but actually companies, in all industries are designing internal ML platforms to power their production machine learning applications. So at Databricks, we looked at this trend about 3 years ago, and we saw that this is a very useful abstraction to build, but at that time, each company was more or less building its own internal platform. So we asked, can we get these benefits with an open source platform that companies can actually collaborate on to make a really great ML platform together? And this is why we started the MLflow open source project, an open source machine learning platform that's designed to be easy to integrate with custom processes you have in your own company. And MLflow's grown quite a bit since then. So MLflow today has 4 components. It's got a tracking component for experiment management and monitoring production metrics. It's got a projects component for reproducible runs, models, a way of packaging models and deploying them in a wide range of systems in a consistent way. And finally, the Model Registry, which is a collaborative, almost GitHub-like environment for sharing and reviewing and naming your models so that a team can work with them. And all these components are designed around general sort of REST APIs that can be used in any language and that are easy to integrate into any machine learning library. So you can bring them into whatever workflow you have for machine learning. So since we launched MLflow, the community has grown tremendously. We're really excited to see how many organizations have adopted MLflow and how many have even contributed code to it. So today we have over 2 million PyPy downloads per month of the project, 260 code contributors, and just on the Databricks cloud service, we see over 1.5 million experiment runs per week where people are training models using MLflow. And the use cases that companies have are also super exciting to see. So as just some examples of our customer use cases, first of all, Daimler, who spoke yesterday at the summit, is using MLflow to manage the lifecycle of models that use various sensors to predict complex physical behaviors in their production process. So as they're producing, machine parts and so on, they actually have all these machine learning models that, try to understand what's going on and maybe predict, if something is going to go wrong. And they're using MLflow to manage the development of those. ABN AMRO is a bank that's been using MLflow for automated and consistent deployment of over 100 models for all kinds of application, including fraud detection, marketing, and logistics. And finally, H&M, obviously leading retail company, has used MLflow to let their data scientists spend most of their time on model development as opposed to tuning and monitoring. So these are just examples of 3 different industries where companies have gotten significant benefits from using MLflow. So in the talk today, I want to discuss a few ways that we're pushing the MLflow project even further to make it even easier to do production machine learning. And these include integration with PyTorch, tracking more types of information about your ML development process and letting you query it, and finally the model registry. So let me start by talking about PyTorch. Last week at the PyTorch Developer Day, we actually announced a really exciting collaboration between the MLflow team at Databricks and the PyTorch team at Facebook, where we've been building a number of tight integrations into PyTorch to let users easily productionize their PyTorch applications. PyTorch, of course, is one of the most popular machine learning libraries today, also the leading one in research, and it makes sense to be able to take those research innovations that people are building and quickly be able to turn them into production applications. And in particular, we announced 3 integrations. There's auto-logging for MLflow and the PyTorch Lightning API to make it super easy to track experiments. There's torch script support in save models, which means that whenever you package a model and you deploy it into any of the supported deployment backends in MLflow, it will actually execute faster using torch script. And finally, there's model deployment to Torch Serve, the serving system that the PyTorch team launched. And all of these also come with a set of detailed examples of using MLflow and PyTorch together that we've been putting together. So just to give you a sense of how easy this is to use, this is some standard PyTorch code that's training a model using PyTorch Lightning. I won't go into the details, but it's just kind of the standard code you might use. And if you want to start using this with MLflow, all you have to do is import the connector and call one line of code to turn on auto-logging. And MLflow will now automatically track a lot of information that you get from PyTorch through this integration that we built. So once you do that, you'll see you get all these metrics in the MLflow user interface, you get training curves, and you also get the model itself checkpointed, and you get even a description of the model. So you can easily keep track of how your experiment is progressing over time, or take this model and push it into the MLflow Model Registry and start reviewing it and deploying it from there. And finally, once you have worked on your model and you'd like to deploy it, it's very easy to call the MLflow Deployments API and tell it to deploy one of your existing models to Torch Serve, and it's going to execute in an optimized way on that system. So this is really exciting to see. In fact, we're super excited to have Lin Chao today give a keynote right after me about all the work that's been going on to bring PyTorch into production, including the MLflow integration. So I'll let her talk about this in more detail and show some of the other things that her team is working on. So that's the first thing we wanted to present today. Really exciting collaboration, and we'll keep doing more work with the PyTorch team. The second thing I wanted to talk about is extending the MLflow tracking component, which has been widely successful to track even more types of information about the ML process, which makes it a lot easier to operate these applications. So if you're not familiar with it, MLflow Tracking is an API to log various information from your development process, and then to get these nice either visual user interfaces or APIs, query APIs, so you can see how your job is doing, both at the experimentation phase to compare experiments, but also in production once it's running to let you easily track how your application is doing over time. And in most libraries, there are these high-level integrations, like these auto-log APIs, where you just call that and we automatically collect, various kinds of information about them. You can, of course, also manually log information. And there are built-in library integrations now with many widely used machine learning libraries. So MLflow tracking has been very successful for tracking metrics and models, but we've also seen that it's very useful to extend this concept beyond that. And so today I'm going to talk about 3 recently launched pieces of functionality to track more information about your process and how they help. So these include data version tracking with Delta Lake, which you heard a lot about yesterday, and Apache Spark. Model schema tracking for correctness of your application, and finally something we just launched, interpretability with SHAP, an integration between MLflow and SHAP. So data versioning is obviously very important as you're developing a machine learning application because it's highly dependent on data, and it would be nice to be able to record exactly what data you used during the training process and then also reproduce this exact same data in the future. Now, doing this with large-scale data sets can be extremely challenging, but fortunately, there is the Delta Lake project, which creates a transaction log for how your large-scale data tables are changing and also supports time travel back to a previous version of the data. So we've integrated this with MLflow through this Spark auto-logging interface that basically logs any Spark data source that your application is reading during training. And for Delta in particular, it also logs the version number that you use. So you can then go back and easily reload exactly that same version of your Delta Lake table and do additional operations with it. So it's super easy to use, again, one API call, but now you get reproducible data versioning for these petabyte scale data sets that exist in Delta Lake. And within the community, there's also work to integrate other data versioning systems, which will hopefully come out, in the future. So that's one really nice tracking integration that recently came out. Second one that just launched a few months ago is tracking for model schemas. So in your model, it's got some input fields and some output fields, and it turns out that these might often change. And a common source of problems in deployment is if someone is passing in the wrong fields into the model. So we've added the concept of schemas to MLflow models, and we have a very easy way to capture those and track them. And all the user interfaces in MLflow that let you compare two models will also compare the schemas now, so you can tell if something is changing and maybe don't deploy that model to production until everyone is ready to pass in the new kind of data into it. And then the final thing that we just launched in MLflow 1.12 is integration with the SHAP library for interpretability. So you can now run SHAP to create explanations of why your model is predicting various things and log those and visualize them in the MLflow UI and compare them across training runs or as your model is running in production to see what's changing over time. So very easy, but very powerful. So overall, our users have found these kind of integrations quite valuable for improving their productivity and reliability with machine learning. And really the goal we're building towards here is to easily be able to log and query all aspects of your ML development process. So we're going to continue investing in this part of MLflow to let you easily build and monitor these production apps. And then the third thing I want to talk about is the Model Registry component, some exciting new features around continuous integration and deployment, and GA on Databricks. So the Model Registry, if you haven't come across it before, is this central hub that lets you publish, version, and review models, a little bit like a GitHub type system, but for your machine learning models. Inside it, basically the way it works is you use the MLflow Tracking API to record a model and information about how you trained it, and then you can publish this model into the registry. And in the registry, you can define the model, add comments about it, describe it, and you can also push in multiple versions of a model and pass them, tag them with these lifecycle stages, development, staging, production, and so on. And as your models are being published, you can have human reviewers or automated tools plug into them and listen to changes and make reports about how they're doing. And finally, there's also a very simple API to load the latest production version of a model or staging or whatever you want and use it in your application. So that's how you would do batch scoring and real-time serving, with the approved version of a model. So it's a very nice abstraction to have, if you want to keep track of what your models are doing and collaborate on them with multiple people. So one thing we're announcing today is that the model registry is now generally available on Databricks. We think, it's ready for prime time. We already have, basically thousands of companies that have been using it. The version on Databricks is also fully integrated for Databricks customers with the user management and security features on there. So you can have fine-grained security around who can develop each model, who can approve changes, and so on. And we are also announcing a bunch of new features for the model registry, both in open source and on Databricks, which include tag and search APIs, webhooks, and comments to make it even easier to integrate this into your development process. So tag and search APIs, these were launched in the open source project. They're a simple but powerful concept. With tags, you can add custom key value pairs on your models, either using the user interface or through an API. And this is a really great way to implement kind of a checklist for how your model is doing. For example, you might have a manually added tag about the model passing GDPR review, so it's actually legally okay to use it. And you might also have an automated system that listens for a new model, tests them, and adds a tag if they pass the performance test. So using this, you can implement custom reviewing workflows based on your organization. And to complement the tags, we also launched a search API that lets you easily search for example, new model versions. And you can use this in your CI/CD applications to automatically run tests on them and automate various actions like deploying the new models and so on. So it's a nice abstraction for just working with your models at scale. The second thing we're announcing on Databricks specifically is we've added support for model registry events as webhooks on your Databricks workspace. So you can now listen in a secure way to events such as a new model version being registered or someone adding a tag or a transition request, and you can hook this into custom CI/CD tools you might have and get callbacks on these events in a secure manner and make changes to the registry. So it makes it even easier to automate your work versus polling the API, because we have this webhooks functionality to send the events to you. And then the final integration, it's kind of small but nice again in the Databricks environment, is the comments feature that we have throughout the Databricks workspace can now be used to discuss changes on models as well, the same way you can discuss about changes on notebooks. So it's super easy to collaborate on them with users that are in that workspace. So we're really excited about what you can do with the model registry. We'll continue adding collaboration and reviewing features into it, and we're excited to announce it as GA. And to show you a little bit more about what it can do, I'd like to invite Casey, our Senior Product Manager at Databricks, to give you a demo.
Thanks, Matei. In this model, we're going to look at two things. The first is how you can use the model registry to manage the end-to-end lifecycle of getting your machine learning models deployed. And the second is how you can use the new model registry webhooks to automate a CI/CD workflow. Let's go see how it's done. The model we're going to deploy is going to predict what price we would have paid for an Airbnb in Berlin had the Data and AI Summit not gone virtual. I'm going to come down here and click Submit, and sure enough, you can see our predicted price. How did we do that? Here we are inside of Databricks in the model registry. You can see I have one model registered, and if I click inside of it, something new you might notice is this serving tab. We now allow you to serve your models behind a REST API endpoint so you can make live predictions. You can see here that version 1 of my model is in production and currently being served. If you logged your models with an input example, we help you build a request out of those input examples and allow you to send a request to test your endpoint in the serving tab. The other cool thing to note here is that we give you two different endpoints that you could call. One that's specific to your model version, and the other that's a generic production endpoint, meaning whatever model is in the production stage will be served behind this endpoint. So now let's look at how we can upgrade version 2 to production through an MLOps workflow using the model registry. I'm now going to switch over and become a data scientist and log into Databricks as a data scientist. When I come in here, you can see that I just pushed version 2 to the model registry. When I come into version 2, I'm going to want to come up to this staging. And in the staging dropdown, I'm going to want to transition my model to production. However, because I'm on the data science team and not on the deployment team, I don't have permission to directly transition my model to production. Instead, I need to request a transition from my MLOps team. Once I submit this request, you'll see it pop up in the registry. There it is. And now I just need to go notify my MLOps team that I have a review that they need to do. Now we're going to go back to and log in as our MLOps team. And when they go to the model registry and they go inside this model version, they're going to see that they have a pending request. One of the things that the MLOps team is going to want to do is compare the new model version to the one in production and see how they differ. So we're just going to check both of these and then click this compare button. Now we're going to get a side-by-side diff view of how our two model versions differ. We can see slightly different parameters were used. We can see that our input and output schema seem to be the same, so those are compatible. And then we can see how our metrics have changed between the two model versions. So we can see, did the model improve or did it not? Once I've done this manual inspection, I can go back to that model version and approve the request. Pretty soon you'll see that our stage for this model version will switch to production. And now, if I go to the model serving tab, you should see that now version 2 is in production and that endpoint is now serving this model. That means if we go back to our website and we click submit, we'll be getting a different price because now a different model is being called automatically. So that process seemed a bit manual. The data scientist had to log in, submit a transition request, reach out to the MLOps team. The MLOps team then had to go into the registry. They had to do a manual inspection on a diff view to see if they had confidence to then deploy this model. This seems ripe for automation. This is where the new Model Registry webhooks come into play. The Model Registry webhooks, tags, and comments that we've added allow you to build your own MLOps workflow and automate it. Webhooks allow you to register callbacks based on various model registry actions. For example, a new model was created or a model transition stages. Tags let you write back information to your model version. For example, does the input schema match? And comments allow you to kind of go a step further than tags and give more details, or even better, allow you to communicate with your teammates on how you can improve the model to make it fit for deployment. So let's see how we can build this. Before we jump into a live demo demonstrating this automated CI/CD workflow, let's look at a diagram that kind of walks us through the architecture here. What's going to happen is our data science team is about to get new Airbnb data, and they're going to want to retrain a new model. After they've retrained this model, they're going to push it to the model registry. When they push it to the model registry, it's going to trigger our first webhook. This webhook is going to call an Azure function, and that Azure function is going to do many things. The first thing it's going to do is run a bunch of tests. It's going to check to see if the schemas are compatible, it's going to run some unit tests, etc. The Azure function is then going to write back the test results as tags on our model version. If it failed, it's going to leave even more specific comments as a comment. And the last thing our Azure function is going to do is it's going to create a transition request on behalf of our data scientist, so they don't have to log into the registry and do that. Now, when that transition request is created, it's going to trigger our second webhook. This webhook is going to send a Slack notification to our MLOps Slack channel, and it's going to notify them that there's a new transition request that they need to review. They're going to send an MLOps engineer to the model registry page where they're either going to approve or reject this request. If they approve it, it's going to get moved to production, and as we saw earlier, automatically served behind that production endpoint. So let's go see it in action. Here I am in my MLOps login, and I'm going to go to this notebook. And the first thing we need to do is actually register these webhooks. So I'm going to come in here, and these first two cells are just setting up some wrappers so that the code later is easier to read. And now we're getting to the fun stuff. Here's how you register a webhook. You can see all you need is the model name, the events that you want to be triggered. So in our case with the Azure function, we want it to be whenever a new model version is created. And lastly, we need to know what the endpoint is of the external service you want your webhook to call. In this case, we want it to be my Azure function, and so that's the schema checker. So I'm gonna go ahead and run this. And you can see it's going to return my webhook, and a webhook has a unique ID, a bunch of other fields, and one that's most important right now is that its status is active. We're going to go ahead and do the same thing for our Slack webhook. And again, the main thing to notice here is that we're triggering it on a different event whenever a transition request is created. And now we're going to go to our data science team and run their notebook that's going to retrain that model with the new data. So when we run this notebook, again, what's going to happen is we're going to trigger that first Azure function webhook. That's going to run all those tests. Then it's going to create the transition request, which is going to trigger our second webhook, which is going to create a Slack notification, alerting our MLOps team that they need to review a new request. We should be hearing the Slack sound any second now. There it is. And sure enough, if we go to Slack, you will see we do have a new notification telling us that a user requested that we transition this version 3 from none to production. And we can go ahead and click on this URL. And now we're taken to our version 3. You can see here that the transition request was automatically created for us by this bot that we created, and that there's all these new tags. You can see that our metrics did improve. The new schema is compatible with the schema that's in production, and all of our tests passed. As an MLOps engineer, now I don't need to look at this visual diff view because I know that my Azure function already ran all these tests for me and they all passed. So I can go ahead and click approve. And now this version 3 is going to be moved to production. And now, again, if we go back to that serving tab, we're going to see that, again, version 3 is now the one in production and is served behind that generic production endpoint. Which means we can go back to the website and click submit again, and we're going to get an entirely new price because we're now pointed to a new model, the updated version. But what if something goes wrong? What if it's not all hunky-dory? Well, we can go back to our notebook and we can have our data science team change something. So when our data science team runs this notebook, they're going to actually end up dropping 2 columns from the data frame, which is going to change our schema. And so the same webhooks are going to get called, or same tests are going to be run, but now some of them are going to fail. There was our Slack notification. And so now we just directly go to the model registry, see this new model version 4. And sure enough, we can see from our tags that our metrics didn't improve, our schema is not compatible with the one in production, and we had some tests fail. And this is where Model Registry comments can come in handy, because if we keep scrolling, we can see that we have some more specific or detailed information below in the comments. We have a comment that's written out which columns are missing, which is helpful information, as well as how many tests have failed and which ones have failed. And this is going to allow me as an MLOps engineer to start a discussion with my data scientists and allow us to start a conversation and collaborate on how to get this model into production as quickly as possible. So we just saw how you can use Model Registry, webhooks, tags, and comments to automate an entire CI/CD process for your machine learning models. Databricks has all the machine learning tools you need to build an end-to-end MLOps workflow inside of Databricks, as well as provides the flexibility with these APIs so that you can build out advanced CI/CD workflows to enable your team to be as productive as possible. Back to you, Matei.
Wow, thanks, Casey. That was a great demo. So I hope this has gotten you excited to try MLflow. You can easily get started with it just on your laptop from the official website. And if you want to try the version on Databricks, that's also easy on our free community edition. And if you're at the summit later today, we also have a free tutorial where you will be able to get hands-on experience with MLflow. So I'm excited, to see what you can do with it. So that's our updates for MLflow today. As our next speaker, I'm really excited to introduce Lynn Chow, an engineering director at Facebook, who is responsible for PyTorch and quite a bit of their other AI infrastructure. And she'll talk to you about bringing machine learning to production at scale, including the PyTorch integration with MLflow.
Hi everyone, I'm Lynn, working on PyTorch at Facebook AI. Today, I will talk about PyTorch mission, transitioning research to production, and the close partnership with MLflow to achieve that goal. Let me start with our journey so far. In 2016, we identified a gap in what researchers need and what's available. We saw the need for a more flexible and easy to use front end for more complicated neural network architectures. A key principle for us was to interoperate with as much of the Python ecosystem as we can and be a good citizen. As a result, PyTorch played well with NumPy and other Python staples. We built Torch Distributed and A10, a fast, low overhead engine, to help researchers innovate on both large and small models. Later on, many researchers became product owners. They asked for better production support and performance. We took this as a challenge to keep research flexibility and yet enable production. In order to serve their needs, we made a huge pivot on PyTorch 1.0. We merged PyTorch with Caffe 2 and built Torch script to enable production. We kept expanding scope to cater to our users by adding major features including PyTorch mobile and quantization. Everyone wanted options on hardware backend, so we work with many hardware vendors to increase hardware portfolios for PyTorch. During PyTorch production development, we discovered huge demand in having the building blocks of serving and deployment, model lifecycle management, workflow management on top of PyTorch. Such ecosystem needs to be modular, flexible, and has extension points to launch to either on-premise settings or various cloud environments. Concretely, we would like to build a cloud-agnostic, open-source, and end-to-end machine learning model experimentation to production workflow. We believe this would lower the cost for many users to productionize their models, but still maintaining a significant amount of customization and flexibility. We're working very closely with Databricks on MLflow to achieve this goal. Now let's step back. Ultimately, there are 4 guiding principles that we worked with. Our community in the center to empower us to build out PyTorch for enabling cutting-edge research, PyTorch to be highly performant with production-grade quality, the PyTorch ecosystem for a smooth user experience and high productivity. However, we're also serving a variety of users. Not everyone needs everything. They should only cognitively pay for what they use. Our ecosystem aims to provide a comprehensive coverage, modularity, and interoperability to allow users to only use what they only care. We recognize how small we are. We have always strived to play well with everyone in the Python ecosystem and beyond. We're not going to have all the innovations and ideas ourselves. PyTorch heavily benefits from co-development with many institutions, key partners, and individual contributors from our community. These principles worked well so far. PyTorch team built a strong community. It has been well supported by the open source community with more than 1,600 contributors, 34,000 users in discussion forums, 45,000 GitHub downstream projects. It is also strongly received by the research community with a lot of citations from newer IPS papers and archive papers. PyTorch in production grew strongly as well. It is widely adopted in industry and also massively adopted at Facebook production across Messenger, Facebook, Instagram, AR/VR applications. Over 85% of models trained in PyTorch, over 1,000 PyTorch models are in production. I will talk about our current progress and future direction of building PyTorch production ecosystem. First, PyTorch has been battle testing production setting at Facebook scale. Over the past year and a half alone, the number of engineers using PyTorch to train new models has doubled. At the same time, each engineer increased the number of workflows and model complexity. We saw 8 times increase in the amount of compute to train these models. In aggregation, we serve over 400 trillion predictions per day to do things like identifying fake accounts or personalizing the content you see. We have enabled AI on more than 1 billion devices serving Facebook family of apps. To understand how we support auto growth, let's zoom into the end-to-end workflow. This is a set of building blocks. It started with obtaining and preparing data, potentially fetching extra signals from feature storage systems. Then we turn data from data frames into tensors ready to be consumed by the model. And then we need to construct the model from scratch or pull the best architectural components or pre-trained components. Then we need to analyze and understand the model and do attribution. And apply AutoML-like techniques from simple hyperparameter optimization to neural architectural search. For serving, we need to shrink and optimize the model to deploy it into a data center or on embedded devices like mobile phones. Underpinning all the above, there is also pipeline authoring and AI artifacts management. The best user experience can only be provided by co-engineering with other awesome projects. There are a ton of opportunities you can help building it up. The scope here is very big. To begin with, we pick a few key challenges to solve. First, it's critical to get reproducible results from performance and accuracy point of view, in monitoring and analyzing any regression. Without that, undiscovered fluctuation will cause production outage. Second, we want AI artifacts to be highly discoverable, and we want to strongly encourage collaboration to maximize leverage. Without that, we'll have a high degree of model proliferation and a model management nightmare. We need lineage tracking for infrastructure efficiency by avoiding redundancy. It's critical for model governance and privacy enforcement as well. We also want to avoid manual workflow from experimentation to optimization and deployment. And here we want a fully managed and automated workflow. And last but not least, we need efficient model serving across server and on-device stacks, especially with versioning across heterogeneous set of devices. At Facebook, we built an internal production ecosystem to tackle these problems. However, externally, we face very unique challenges, as in there's very diverse infrastructure options. That's where Databricks, Facebook, and many other companies join forces to tackle these challenges, and we're building out a PyTorch open source production ecosystem. To get into a little bit more details, what we're building. First, We use auto-logging to enable machine learning model builders to automatically log and track parameters and metrics from PyTorch models in MLflow. We use PyTorch Lightning as the training loop to add support for auto-logging. Second, we add many PyTorch examples with MLflow projects. And third, Torch script is what we recommend for production model serving. It's a subset of Python language optimized for machine learning applications. Now you can save and load Torch scripted models with MLflow Model Registry. TorchServe is a PyTorch model serving library that accelerates deployment of PyTorch models at scale with support for multi-model serving, model versioning, A/B testing, model metrics. We built an MLflow TorchServe plugin to deploy PyTorch models in diverse serving environments. This is all super cool and exciting. For more information, Gita from PyTorch team gave a deep dive of PyTorch and MLflow integration yesterday. Check it out. We have detailed examples and documentation to get you started on MLflow and PyTorch. Please try it out and let us know what you think. Thank you for watching this talk and look forward to working with all of you in building PyTorch MLflow production ecosystem.